Hey guys, welcome back to Tekneikos. Today we are going to look into deployment and replica set in K8s or Kubernetes. Okay, so this is very important video in terms of deployment and replica set. So before we go ahead, and I want to tell you that this video is coming after Pods and Namespaces video. You can go and check out my YouTube. You will find Kubernetes, Pods and Kubernetes introduction and architecture, and another video is scheduled for Namespaces. These three videos are prerequisite. If you come after watching that would be very helpful for you to understand K8s from basics. So I am going to teach you this from scratch, like you never ever heard of Kubernetes deployment or replica sets. So let's start. I hope you have already watched my Kubernetes pods video. So let's start with this. So pods are temporary. We have already seen this, that pods are temporary. If a pod crashes or gets deleted or node running the pod goes down, the pod may disappear. Okay, so they are ephemeral in nature. We have seen it. So in production, we do not manually create pods and hope they stay alive forever. This is very important line I have written in the notes. Instead, Kubernetes provides deployments and replica sets to make sure the required number of pods are always running. This deployment is not the deployment that you think of. This deployment is a Kubernetes object. So Kubernetes provide an object named deployment and another object called ReplicaSet to make sure the required number of pods are always up and running. We are going to understand why it is important. So as I told you that a pod alone is not enough for production. For example, suppose you are manually creating one nginx pod. Okay, if the pod crashes, your application goes down. Nobody recreates the pod automatically. Traffic stops working. Okay, that's why the deployments exist. A deployment keeps checking whether the desired number of pods are running or not. If the pod dies, deployments creates a new pod automatically. This is called self-healing. Let's understand the flow. You define in your YAML or however you write that I have one application nginx and that needs to be run as a deployment. So your deployment gets created, your replica sets gets created, and you define the desired state as 3. So it will make sure in a node there are 3 pods up and running always. Okay, so this is the same thing that I explained you. Replica set in Kubernetes is an object that makes sure a specific number of identical pods are always running. So if you define 3 pods to keep on running, it will make sure that are always running. Okay, so if you define same thing I have written here, replica set creates 3 pods. If one pod crashes, replica set creates another pod. If one extra pod appears, replica set removes it. If you get another pod, it will disqualify or remove it, because in your YAML definition you have mentioned that you need 3 pods. Now we have seen what is a deployment. Deployment is a high-level Kubernetes object. Deployment manages replica sets. Deployment helps with creating pod number 1, scaling pod number 2, updating pods number 3, rolling updates, rollback, and self-healing. Self-healing we have seen, rollback we will see, rolling updates we will see, updating pods we have seen, scaling pods we have seen. Okay, creating pod we have seen. So deployment is what we use in real-world production systems. Replica set usually works behind the scene. I told you with the help of this example that we have deployment. We create a deployment. It creates a replica set. As we mentioned, it creates 3 pod as we wanted. Okay, let's understand the difference between these two concepts, deployment and pod. So pod is just one pod. It does not create it automatically. It does not scale. It does not give you ability to have a rolling updates. It does not give you rollback access. Okay, or there's no rollback, you can say. In deployment, on the other hand, we have automatic creation or recreation of pods. It can scale pod. It supports rolling updates, it supports rollback, it is a production ready way of deploying your application. Let's understand how do we scale our application. So for example, the initial pod is 1 and 2 running in a node. Okay, now you increase the traffic, you have more number of users. Initially it was for example, let's say 10,000 users / month. Okay, I guess not month, per day. Okay, now you have 1 lakh users per day. Okay, then you need to increase the number of pods so that your application can handle that much amount of load. So initially you were having 2 pods. Now you need to scale it. You need to scale so that it can handle 1 lakh user per day. Now you have to create 5 pods. Now your application can handle 1 lakh user per day. With pods, you are not increasing just the pod, you are increasing the memory size, you are increasing the CPU, you are increasing a lot of things. But multiple pods gives you a more reliable, more scalable way of serving your traffic. What I have written, suppose you are running one nginx version 1.2.4. you need to scale, okay, or you need to upgrade your nginx version from 1.2.4 to 1.2.5. so once you change the version of nginx, in your YAML file, I will show you practical example, don't worry. And for example, your 3 pods are running. Okay, it will not directly go and delete all 3 pods and create another 3 pods. This is not how rolling update works. It will create 1 new pod, removes 1 old pod, and repeats the same thing gradually. With this example, you can understand. So initially, old version was all pods running with nginx 1.2.4. okay, it should be 0.4. Then a new pod created with the nginx to 1.2.5. 1 2 3, let's say it is 4, it is also 4, it is also 4. Again a new pod created with 5 and it deletes. Again a new pod with 5, it deletes. Okay, it deletes the previous pod. Again a new pod with 5, nginx 1.2.5, and it deletes the older pod. Now your replica set mentioned 3 out of 3. So all 3 pods are running with the latest version. So you can see a egg becomes a baby and it is a caterpillar and slowly it becomes butterfly. So this shows how Kubernetes behaves behind the scene. Slowly it adds new pods, slowly it removes what is already existing, and at the end of the day you get your new up and running version of your application. Now we have seen a lot of theory. Let's come to some commands. These are important commands that you need to remember. In this we are creating a deployment using command line. I will show you practically using my Minikube setup. I have already created a video regarding that as well. So let's have our terminal opened side by side. We will run these commands. First we need to start the Minikube start. Okay, the Minikube is not starting because, okay, got it. I need to start the Docker first before starting the Minikube. Once the Docker engine started, we can start the Minikube now, I guess. Minikube start. Let me allow this, and it's restarting the existing Docker container for Minikube. Okay, we got the Minikube up and running. We can run all these commands. If you have not seen my video, you can go here and you can watch the Minikube Kubernetes setup here, this video, and you can set it up for you. The first command says we are using Minikube kubectl create deployment. So we are creating one object called deployment, which we have been learning about, and then we are creating one nginx deployment. Okay, image nginx, and let's see how this command runs. So kubectl create deployment nginx deployment. So deployment is created. Kubectl get deployment. We can see we are having one nginx pod being created and it's running. You can see the ready state is 1 out of 1. So similar to what I have mentioned, we can run the command kubectl get deployments to check the deployments. We can run kubectl get replica sets to check the replica sets. Let me check that as well. Kubectl get replica sets. Desired state is 1. Current is 1. I told you if I make the desired 3, so it will make sure that current is also 3. Okay, currently the desired is 1, that is why the current is also 1. So this is how I teach. If you are liking my teaching style, if you are liking how I am breaking down all these concepts and showing you practically, so please hit the like button and subscribe to Tekneikos. Let's understand how many pods are running. We can get this by running kubectl get pods. Let me run that command as well. Kubectl get pods. So currently our nginx pod is running, nginx deployment, and we have a backend service pod which I have created in my pod tutorial, I guess. That is also running. Leave it. Okay, I told you we will scale it. So let's scale kubectl scale deployment nginx deployment to replica set as 3. So we will make it 3 by 3. This is desired, this is current. Okay, so let's do that. Let's run the command kubectl scale deployment nginx deployment replicas equals to 3. You can see deployment.app nginx deployment scaled. Okay, we can check kubectl get pods. You can see we have 3 pods up and running here for the nginx deployment. We can also get the deployments. It is 3 by 3. You can see here. Let me clear this and let me run the replica sets. You can again see here desired is 3, current is 3. We can expose the deployments. Okay, this is something else. So kubectl expose deployment nginx, then node port 80. Okay, if we do this, we can get the deployment service similar to what I have shown you in the command line. The same thing I have mentioned in the form of YAML, so that you should also know how do we create YAML files. Both are important in terms of your interview. They might ask you to create a YAML for a deployment, so we will also see that. I am making you interview ready, boss. Don't worry, I will make you interview ready. So I have some bunch of files. I guess I have created already a folder. Let me open that. Let's create one file, deployment.yaml, and we will write our content here. API version, we have to mention it first, app/v1. Other thing we need to mention that is kind. We are going to create a deployment. Okay, then the next thing is metadata. Name should be demo nginx. Then we need spec. Inside that we will create replicas of 3, and we will need selector, match labels. App name is going to be demo nginx. Let's have a template. Metadata, labels, app demo nginx. Containers, we will have to name the nginx container, nginx container. We need to define the image as nginx. Then we have to enable some ports. Okay, nginx. Then below that, ports should be container port 80. Okay, so I always make sure that indentation is correct. Fix indentation. So this is a very good practice that you ask AI not to create the YAML file but to check your indentation. Okay, this is very important. Before you push anything to Kubernetes, you must make sure that your indentation is correct. Okay, indentation is correct, I guess. Now we will go to the same directory where we have our file deployment.yaml. Now kubectl apply -f file, then file name deployment.yaml. We are going to apply this deployment YAML. It is going to create a deployment called demo nginx, and this is going to run our nginx application with 3 replica set. Let's run it. Now it will create one deployment called demo nginx, and it will run our nginx image. It will make sure that 3 replicas are running. Okay, so let me run the command kubectl get deployment. We can see demo nginx is running 3 out of 3. We can get kubectl get replicas. Okay, ReplicaSets. You can see the demo nginx is running 3 out of 3. Let me go back to our notes. So what we have done, we have created what nginx image. We have mentioned API version, kind is deployment. Kind should be deployment. We are going to create deployment, so it should be deployment. Then metadata. Then comes specs. In specs, we define ReplicaSet to be 3. Then we have a selector. We have template and then container, which image we are going to run. Okay, I hope this is clear. Let me open the notes again. The same thing I have done here. You can also check the ReplicaSet YAML. Now let's understand the important difference between the deployment and the ReplicaSet. So ReplicaSet only ensures required pods are running, but what deployment provides us, it provides us rolling update, rollback, scaling, version management, easier upgrades. Okay, so this is why we rarely create ReplicaSets directly. Usually deployment creates ReplicaSet automatically. We just have to mention how I have mentioned here. Okay, in the line number 8, let's understand the rollout command. We have kubectl rollout status deployment nginx deployment. Okay, let's run this command and see what is going to happen. So I'm doing this with curiosity so that you understand how actually we can learn or master Kubernetes, because it is not something that I teach you overnight. There are a lot of concepts involved that I have to teach you by doing. So we have run this command. Now let's check the rollout history by running the command. Okay, let me kubectl rollout history deployment nginx deployment. You can see we have one revision and we have seen this command. So I hope you understand these commands. The first command we run for kubectl rollout status, this shows us whether the deployment update is completed successfully or it is still running. The second command was for rollout history. So this rollout history command, let me run this. This shows us all previous versions or revisions of the deployment. Whenever you change the image, replica count or configuration, Kubernetes stores a version or revision, and this command lets you see those past versions. Same thing, this undo command, what it does, this command is used to roll back the deployment to previous working version. Okay, suppose we have 1.2.4, 1.2.5, we can roll back. Okay, then there is update image command. This is used to update the image used by the container inside the deployment. So here it changes the nginx container image to version 1.2.5, and Kubernetes starts a rolling update by gradually replacing old pods with new pods using the new image. Though some of the important interview questions we need to understand. So what is the difference between a pod, a ReplicaSet, and deployment? A pod is the smallest unit in Kubernetes that runs the container. Okay. Now ReplicaSet ensures a fixed number of pods are always running. Then what the deployment does? It manages the ReplicaSets and provides scaling, rolling updates and rollback and self-healing. Now why deployments preferred over pods? Deployments are preferred because they can automatically recreate failed pods, scale pods, perform rolling update, perform rollback. Okay, a normal pod cannot do that. What is the difference between deployment and ReplicaSet? I told you again and again, ReplicaSet only ensures the required number of pods are running. Deployment does more. It creates the ReplicaSet, it handles rolling update, rollback, manages version change. I'm explaining you this again and again so that it gets concrete in your brain and you won't fumble while answering these questions. What is selector and match labels? Selector is used by deployment or replica set to identify which pods belong to it. Okay, I told you I have already used here selectors. It belongs to demo nginx. So we do selector match labels app nginx. This means deployment manages only pods having label nginx. Okay. What is desired state in deployment? Desired state means the state you want Kubernetes to maintain. For example, I want 3 pods to be up and running always. So it will make sure that 3 pods are up and running always. What is current state? Then what is the number of pod running right now is the current state. Thank you for watching. I hope the video actually helps you to understand deployment and ReplicaSet. If you like, please subscribe to Tekneikos. You can connect to me directly through my LinkedIn or through video comments for any further doubts you have. Thank you.